today we're going to be talking about working with Civil 3D projects in RoadEng Softree Optimal. And thank you for, waiting 5 minutes without any sound to see and hear this presentation. We're pretty excited about it ourselves. It's been in development now for over a year. And really, it's all about how do we take our projects from the AutoCAD and Civil 3D environment, put them into RoadEng Softree Optimal, and vice versa. And this is all kind of following through since we became a member of the Autodesk Developer Network last year. So the key principles that Craig's going to cover today in this interface discussion really are, the 3 different types of information that we use to communicate between Civil 3D and our programs, RoadEng Softree Optimal. That includes, surfaces, alignments, and cross-sections. So for surfaces, we're talking about the original ground and the subsurfaces. For alignments, we're talking about both the horizontal and vertical alignments for our corridor center line. And then for cross-sections, it gets a little tiny bit more complicated, especially with static and dynamic cross-sections. And Craig's going to cover some of the nuances around that. But for the most part, all 3 of these pieces of information are, reasonably easily transferred back and forth now between RoadEng and Civil 3D, making your design workflows a lot easier. So, Craig, over to you.
Thank you, Erin. Good morning, everyone, and welcome to today's presentation on working with Civil 3D projects in RoadEng and Softree Optimal. Just a couple of quick comments. Apologies again for the audio issues. A couple of quick comments. The version that I'm going to show you today is actually a pre-release version, which means it hasn't been it hasn't even made it to beta testing yet. We hope to have it available in beta in the next month or so, but I can't make any promises about the timing of that. You, as attendees of this meeting, will be informed of that, and we will provide you with all the terms and conditions that go along with that program if you're interested in getting involved. Another thing I wanted to just mention is that the title is Interfacing with the Civil 3D Environment, but really a lot of these features apply to other environments such as Bentley Open Roads civil products. 12D, we're actually working with them, or some consultants associated with them, and also other programs like Carlson and many others. These techniques will work for moving data back and forth between these different civil design packages. The last thing I just wanted to mention is that I'm going to focus on road design, road engineering, because this seems to be the most interested in that. There are things here that would apply more to site design and grading and that sort of thing, but I'm not going to get into them. I think for, that's a future demonstration. So with that, maybe we can start and have a little closer look at the components that that Erin has mentioned. So the first one is surfaces, and by this I'm talking about tin surfaces. Fortunately, tin surfaces are very easily transferred between Civil 3D and Softree products. LandXML works very well for smaller files. That would be things like total station surveys or smaller surveys. LandXML works very well. For larger files, LandXML also works, but it's hugely inefficient. If you've got a large LiDAR data set, you probably don't want to put it into the LandXML format to transfer it back and forth between Softree and Civil 3D. Instead, with a large LiDAR data set, I think it's much better to work directly from the original LAS or ASCII data. Just simply take that data and bring it into the environment, either Civil 3D or Softree, and retin it. There's no, it's in many ways it's a lot simpler because you don't have to worry about things like break lines and all that sort of stuff. So with larger file formats, we recommend working directly with the data set, large data set. But for the most part, surfaces are very compatible. You can move them back and forth quite easily, and I will demonstrate that hopefully today. The next thing I want to talk about is alignments. And these are also very, very portable between the Civil 3D environment and the Softree environment. You can take, and we'll show you this, that you can take a horizontal or vertical alignment, move it out of Softree, bring it into the Civil 3D environment, and you'll have all your curve information and everything will be preserved. Works very nicely, and the same thing goes the other way. One little caveat, right now Softree, RoadEng, and Softree Optimal are single alignment software. That may change in the future, but right now you're working with a single main centerline alignment. If you have other alignments, just for example the edge of a road or a ditch line, those alignments would have to be brought in as a polyline, simply a polyline. So there's a couple of extra steps to bring in other we call them controlling alignments, into the Softree environment. Coming from the Softree environment, those features, the centerline feature would be an alignment, a land XML alignment, and the other alignments that are derived from that, for instance, the bottom of a ditch or edge of pavement or whatever, those would come in as polylines. So the alignment I'm talking about here is principally the centerline alignment, but it's very compatible. And the final thing I wanted to discuss and probably spend the most time here is cross-sections. They are generally the most difficult part of the whole compatibility between any design software. Unfortunately, the land XML environment does not support dynamic cross-sections, and that would be for Civil 3D people, that's your assemblies and sub-assemblies. That is a tricky area. However, the good news is that static cross-sections are quite compatible. So you can bring static cross-sections out of RoadEng and into Civil 3D, and I'll demonstrate this for you quite seamlessly. Bring them into Civil 3D where you can do whatever you wish with them. You can produce construction documentation, or maybe upload it to some sort of data collector for stakeout, that sort of thing. The static cross-sections work very well, and I will show you how that works. On the other side is dynamic cross-sections, which is tricky. And I'm going to show you some. This is where the new software kicks in a little bit, and that if you want to take a project from Civil 3D, you've got a design, and you want to check it, possibly optimize it, maybe do some construction quantity work, but you may need to change the template. You need to change the alignment and have the template behave in a reasonable way. So that is an area that I'm going to show you how we can do that. We can take a Civil 3D cross-section and approximate it in our software. Unfortunately, going the other way, going in the case of a dynamic cross-section from Softree back into Civil 3D, there is no way to do that. So what you have to do there is you have to bring in your surfaces and your alignment, and then in Civil 3D you have to set up your assemblies and sub-assemblies and so on. So let's, with that, jump into a demo. And okay, first thing I want to show you is a typical workflow for moving data from RoadEng into Civil 3D. So what I've got here, for those who are RoadEng users, you'll recognize it right away. I've got a plan view, profile, cross-section, 3D window, and RoadEng, as we all know, is good at very quickly moving things around, interactive, fast, calculating things very dynamically. So in this environment, I've got a design, and I want to move it now into Civil 3D. So the first thing I'm going to do is I'm going to save the alignment as an XML file. RoadEng Civil 3D. I'm going to choose XML, and I've already done this before I got on the phone here, so I'm just going to overwrite the file that I've already created. It's an XML file, and it pops up this complicated looking dialog box. Essentially, this information is for outputting cross sections, and it's actually not that useful in Civil 3D. It's used more for exporting cross sections to a data collector. So I'm actually just gonna, well, I'll just leave it on. It's not gonna hurt, and I'll just save this file. It's gonna save the horizontal and vertical alignments with all the curve information intact. It's very quick. The next thing I want to save is the cross-section subgrade surface. I could save any of the roadway surfaces, but I'm just going to export the cross-section subgrade surface. And to do that, I actually have to go through the terrain program at this stage. So I'm going to save as a terrain file, and I'm going to call it Bluff Road Subgrade. Press OK here, and now I'm going to just fiddle with these options here to only, I don't want any feature lines, just going to remove those. I'm just going to export the subgrade, and I'm going to create a boundary around it. Some details here that probably aren't really too important for this demonstration, and I'm going to open it in terrain when I'm finished. So let's just go ahead and do that very quick, and there we go. I've created a subgrade surface, and I'm now looking at it in terrain, and you can see what it is. It's just the portion of the cross section in the disturbed area. So now that it's in a terrain format, I can save it out as an XML surface, which will then bring into Civil 3D. So I'm just saving Bluff Road Subgrade.xml. Exists, yes. Okay, so we've exported the alignments. I've just exported the subgrades. The other thing we want to get, of course, is the original ground surface. I'll just open that. That's in here. And there is the original ground surface, and I'll just save that out as XML. And again, as I said before, the surfaces are really pretty easy. Not much to worry about. They come across quite well. Just overwrite that. Okay, so close a few of these windows. We've got, leave this one for a second, and I'll switch over to Civil 3D. Now, a bit of a disclaimer, I'm not the expert here on using Civil 3D, so you may see me stumbling around a bit here, but I'll do my best. So I've created these surfaces. Let's create a new Civil 3D file, drawing, and there we go. And now I'm going to, in the Insert tab, I'm going to insert land XML files. It's actually quite easy. I grab Bluff Road alignment, bring that in, get some messages about what's in the XML file, just bring it all in. There's our alignment, horizontal and vertical. If we look here at the alignments, you can see there's a horizontal, and I've also got the profile for that alignment. Okay, let's just bring in the surface. Let's grab the original ground surface first, doesn't matter. Bring that in. There's our surface. Yeah, it's all good. It's got with it. It's got with it everything. I can even just have a look. Yeah, here it is. That's our surface. And I'll do the same for the subgrade surface. So we've got the two surfaces that I wanted to track and an alignment, and then of course I can do various things with that as Civil 3D users know. Notice that I don't have any corridor. I've just got a surface, but you know, I can, let's say I want to create some sample lines here and some cross sections. I'll go ahead and do that. Choose my center line alignment. Say OK here. Here's where I'm hoping that I can not get tripped up. OK, I'll take all these defaults for section width and so on. And I think that's it. There they are. There are my sample lines that I've cut, and I can create a cross-section view of them. Okay, next, great. And there they are. I didn't change the styles and so on, but you can see we've got the road subgrade surface mapped into the section and the topographic surface. So, and of course I could create a profile as well. Let me just quickly do that. Create a profile view. I'll just go quickly here, not worrying about styles and things like that. Maybe pop that up here somewhere. There you go. So in a nutshell, you've got the basic nuts and bolts of the design: cross sections, profile, plan view, surface, in a Civil 3D environment. However, you can't change it. If you want to move the alignment around, you have first of all no corridor, and we haven't assigned any assemblies. So that is what you're stuck with in the Civil 3D environment. I guess that's really all I wanted to show you. The other thing that you can do, if you're just interested in doing drafting, you can save from the RoadEng file. You can, let's just call up an output sheet here. Does this look like not another example? Where I'm going here is that you can simply save a sheet layout or cross sections in a drawing format and bring them in to do drafting, annotation, and that sort of work as drawings. And before I got online here, I did have one that I did saved it out. I'll just quickly open it. You can see what that looks like. There, it was part of a multi-plot. It could have been anything, any component of RoadEng, but warns me that it wasn't produced by Autodesk. And there it is. There's an output sheet, and of course you're in CAD now, and you can do what you wish with it. But it hasn't preserved any of the geometry that the other process that I was showing you did. It's just a drawing. Okay. Don't have a lot of time here, so I got to move on. I'm going to now just close this and open up. I'll close this so I don't get confused. I'll open up a design that was derived from Bluff Road, the RoadEng version. I made it. I was quite proud of myself, and it's to represent a design that was done in Civil 3D, albeit it's a fairly simple design. But this one we can look at. You'll see it's got It's got a corridor, and it's got assemblies assigned to it. I assigned a very simple road cross-section, and it's a full-on Civil 3D road design. So what I can do with this, let me just rebuild the corridor, is to just what I did with the RoadEng side. I can save the surfaces out. So let's just do that. I click on the surface, export to LandXML. I could have done several of these at once, but I'll do them separately just to keep things a bit more organized. So this is going to be the Civil 3D to RoadEng. This is going to be OG surface XML. Already exists because I did it before. Saves it out, and it's a small surface, so I'm okay with doing it via LandXML. The corridor surface, which was created from the corridor, so Civil 3D users know what this is all about, but it's essentially when the corridor is built, this surface is automatically created based on links from the assembly to make the corridor surface, and you have to do things like set up the boundary and so on. But after the corridor is run, you'll have the corridor surface as a surface, and you can save that as a LandXML. Now, if you had other surfaces, maybe rock surfaces, I don't know, any kind of surface here, you could do the same, and you can bring those surfaces into RoadEng, and actually, okay, I'll call this subgrade. You can bring those surfaces into RoadEng and use them in RoadEng in various ways. The final thing I'll do here in this environment is to save the alignment, which is here. Center line alignments, I've got a single center line alignment. Export to LandXML. I'm just going to take all this stuff that comes with it and save that out as an alignment. There was a little bit of an issue here in the way this is organized. You actually, for what I need to show you, the subgrade and the alignment should be in the same file, and that is what I've done in this file. Yeah, when I exported, I should have had both checked, but we'll just carry on here. Okay, so I hope everyone's following me. Is there some way to ask questions, Erin? Here, is there some way to?
Yeah, so I think this is probably in my intro spiel when we were muted, but for the folks that have yet to discover the question panel, it is in your GoToWebinar panel. It's the second box from the bottom. You can ask questions there, and I've got it up on my screen here, so I'll be monitoring throughout the presentation and answering them on the fly.
Okay. Well, by all means, jump in if you have questions. So I'm going to switch now back again to the RoadEng environment. Just minimize this. I've saved my alignment and surfaces. I will go over, and this was the other road design. I hope you're not getting confused. I'm just going to create a new road design, file new. Now, when you create a new road design in RoadEng, it asks you for a surface file, and I can tell it I want to use LandXML for my original ground surface. Let's just do that. Do I wish to save the current design? No. So I've given it an original ground surface. It's looked in the file, and it's found OG was in that XML file. Some options here not to get too concerned about. And then it prompts me to save this in a terrain format. Just do that, og.ter, to keep track of what, okay, yep, we're in the right folder. Now it prompts me, and this, for RoadEng users, you might see this looks a little bit different. We've just reorganized it a bit. I'm going to choose LandXML as my starting alignment file, and then where it prompts me here, I'm going to choose the corridor surface, which we didn't actually create here, but I created earlier. This corridor surface has in it both the subgrade surface and the alignments. So I'm going to choose that. And in the file, it's found there's an alignment in there called Bluff Road, and it sees there's a vertical alignment called FG Center. And I've got several options here for cross sections. The first one is standard RoadEng template, which means you're going to create the RoadEng template in RoadEng and just simply apply it. Let's just have a look at how that works. And there it is. Our default template in RoadEng was set up as such, and here is the alignment now. It's come in, same surface, same horizontal vertical alignment, but we've chosen a RoadEng cross section and applied it to it. Of course, you can change the RoadEng cross section. It's very similar to assemblies and so on in Civil 3D. We have quite an extensive library with these components in it to choose from, so you have lots of flexibility for creating cross sections in various formats and so on. However, that does require work, and if you want to just do a quick optimization, you probably don't want to get into setting up different cross sections and so on. You'll probably want to do this in a slightly different way. So here's where we get into the problem of portability of the cross sections, and let's look at one of two ways that we've got to do this. I'm going to just create a new design again, same thing. This time I won't bother to bring in the land XML, I'll just use the original ground, which we already have. And initial alignment, I'll tell it land XML. And this time again, I'll choose the corridor XML and pick my vertical. And instead of using standard template, I'm going to choose this one, XML surface. So what it's doing there is looking in the land XML file. It sees that there is a surface in the file, and it says I'm going to give you the option to choose one of those surfaces to represent your cross section. It also lets you choose a section spacing, which I'll explain a little bit more, but essentially in RoadEng environment, this is going to make what we call fixed cross sections. Let's just go ahead and do this. Comes in, prompts me what I want to save the subgrade surface as. How are we doing for time? Oh. Okay, so now we've got we brought everything in, but instead of using a RoadEng assembly or template, we're working with the subgrade surface that was developed in Civil 3D. And you can see here, if I bring up the fixed section window, we've got a 25-meter spacing, which I specified. We've got different cross sections, and you can see that that cross section should match exactly with the Civil 3D cross section. So right now, if you were doing construction staking or you wanted to do some pay quantity calculations, that sort of thing, you can do it. You can get in here and do that. Also, what's interesting is that this cross section will move around a bit. It doesn't do it perfectly, but it maybe moves around well enough so that you can optimize this alignment. So picture the situation. You've got a road design, you've done it in Civil 3D, want to know how close it is to optimal. You bring it in, here's the cross-section it uses, and in order to vertically optimize it, it has to move the alignment around. So let's just see how this cross-section, which is calculated from the subgrade, is going to behave when we move it. And you can see that there's some smarts in here that actually say, oh, I'm just going to extend that last slope. Where it doesn't do well is when you get down here and it thinks, or it should have a ditch. Well, it doesn't have a ditch. It's not smart enough to figure that out from just the simple subgrade surface that it had, so it's extending it. again, if your purpose is just to get a quick optimization done to see what you're working with, you may accept this vertical movement as a good enough approximation. You can also use this as a reference and then build a template in RoadEng, and then away you go. You can do a detailed optimization. It's just an approximation of your cross section. Okay. Right. So essentially, at this stage, we're ready to do some design tweaking or optimization with this quasi-dynamic cross-section. Now, the last thing I want to show you is a project that we've been working with another company, Civil 3D Experts. It's still a work in progress, but it is a new plugin for Civil 3D, which is going to provide a smarter cross-section. And I'll just load that up here, and we can have a quick look at it. It's called Export Corridor. Load that up. And what it is going to do is it's going to sample the behavior vertically of the Civil 3D assembly to create a series of snapshots, vertical snapshots of that assembly behavior. So then when we get into the RoadEng environment, it's gonna behave a little better. So let's just go ahead and do that. I specify an alignment. I needed a sample line group, which I had already created, and the sample line group has in it a corridor surface. It has my corridor subgrade surface in it. So I pick that, corridor subgrade. I choose the corridor. This should work with multiple corridors when we get it all working perfectly. I give it a vertical deflection limit that's above and below the existing vertical profile, and I give it an increment, and I'll explain what that is in a second. And I just go ahead and do this. It starts some calculations to capture the behavior of the Civil 3D assembly or assemblies along that corridor. It's finished, and it's produced what's called a CSX file. And that CSX file we've published the format of it. That's the file that we are using to make cross-sections smarter. So let's go back here and create a new design this time. New. Again, we'll choose the original ground surface. Don't want to save this design. Land XML file again because we need the alignment. Choose our corridor XML file. Choose vertical. Now this was the third option here. We looked at standard template. We looked at the corridor surface or subgrade surface file. This is the final one, the CSX option, which now we specify a CSX file and read in the Civil 3D design. Some parameters here that probably don't have time to explain. Brings it in, and now we've got cross sections, and by the way, these were the spacing of the sample lines, so you can control the spacing of those cross sections. That was your Civil 3D sample lines. And if we look at the cross section now, it's a bit smarter. These are the positions where it's been sampled in Civil 3D. So if we come down here, all of a sudden, we're down far enough, it realizes we need a ditch. So we have a smarter template. It's not perfect. It's not perfect. Like maybe in here, it's not putting a ditch in. If we had sampled it more densely, we'd get better behavior. But it's starting to resemble a pretty good approximation of the volumetric quantities that are involved from that Civil 3D file. So we're kind of ready to go here. We can now take this alignment and optimize it. That's it. just to wrap up what we did. So we started in the RoadEng environment. You might be doing something there like a preliminary design, or maybe that's the environment you like to work in. It's just you don't do a lot of road projects, so you're comfortable with a lighter, easier software. You do the work in RoadEng. When you're finished, you save it into Civil 3D for drafting or for someone to take further to set up assemblies and do more detailed design and that sort of thing in the Civil 3D environment. So that's the first thing tried to show you. And the second was to take a Civil 3D project, bring it into RoadEng, and maybe do some design checking. If you use the dynamic cross-section approaches that I described, you can do some optimization, and you can certainly do construction quantities using the subgrade type format, construction pay quantity calculations in the RoadEng environment. That's all I have to say. So I'll pass back to Erin.
Great, thanks, Craig. And again, thanks to everyone who joined us today for our webinar, and apologies for our small technical challenges that we had at the start with our audio. Some upcoming webinars, which I would like to go out on record saying none of these will have audio challenges. So we've got grading and pad design coming up next on January the 22nd, Designing Outside the Box, which is a closer look into Softree Optimal, which unfortunately Craig didn't have time to do a quick example of today. So we're going to be going in depth and taking a look at what Softree Optimal can do in corridor design, and that's on February the 5th. LiDAR-based road design, horizontal vertical curves and county road design, and earthwork optimization, what happens beyond balancing, are all upcoming topics. You can find these and the registration for them on our Softree.com website. And that's it. So thank you all for joining again. Have a great rest of your day.